Okay, we just finished a lesson about proving triangles congruent. And if you remember, the last lesson we did was side, 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 and side, angle, side. Well, this is kind of the same. So we're not going to go through a lot of the explanation at the beginning. We're just going to basically show you some things and use the rest of the time just to do a few examples and some proofs. Because I think the more examples that you see of proofs, to prove triangles congruent, I think the better it's going to be for you. So let's just talk about this briefly. Let's do ASA. Now, you know that SSS stood for side, side, side. I copied and pasted this. We'll make them look just the same right next to each other. But remember, you could take this and you could like flip it around. Watch this. You could take this and, did I do this right? Yep. And you could flip it around, okay? Does that mean that they're not congruent anymore? Okay, I could take this and I could flip it over. Watch, if I do this thing, transform and reflect over the y-axis, then look at that. Okay, I turned it around, flipped it around, but I didn't change the shape of it at all. The shape is exactly the same. So let's get rid of this. Let's just make it look the same just to make it easy because we're just trying to explain this stuff here. Don't want to get too crazy on this. So if we call this triangle ABC, I don't know, let's call it PQR, be a little different here, okay, than DEF all the time. So here's the thing. Here's what they could give you. They could give you an angle. Let's do that in a different color. They could give you one angle equals another angle. They could give you another angle right here that's equal. And let's see what else they tell you. They can also tell you a side. Notice where that side is. The side is in between. It's called the included side. We talked about included angle last time. This is the included side because it's in between those two equal angles. Again, you don't have to show all 6 things that are equal on each other. I didn't have to say that A and P are equal. I didn't have to say that AB and PQ are equal or that AC and PR are equal to each other. This is all I needed to say. By the way, these are all theorems. You can actually prove these things. We're not going to do that for you. I think they might do it in the book, or you can look it up on YouTube or something and somebody might prove these for you. I just want to go do some other proofs instead of proving these. So if all I had was 2 angles and an included side, notice where that side is. It's in between those 2 angles. If I have that situation, I can say now that these triangles are congruent. So if I called this triangle ABC, I can now say that triangle ABC, let's go in the right order. We went from no arc to 1 to 2. So no to 1 to 2 would be PQR. Now, I could say that these 2 triangles are congruent, and why? What would my reason be? My reason would be angle, side, angle, because the side is in between the 2 angles. Here's another situation. I've got 2 triangles right here, and what if they told us this? What if they told you that, let's try a different color again. I want to make those different than those points. Okay, what if angle L was equal to angle X? What if I told you, or they put the numbers in here, they could have said this was 30 degrees and they could have said this was 30 degrees, all right? They could have done that. I'm just going to put the arcs. So what if these 2 angles were equal, and let's say that these 2 angles were given that they're equal to each other, and they told you that this side was equal to this side. Now, what do we have? Is this side angle side like we did the other day? Is it side, side, side? No. Is it what we did just a minute ago? Is it angle, side, angle? Well, it's not angle, side, angle because look where the side is. The side is not in between the 2 angles. The side is the we'll call it the non-included, which means it's not in between. That's just a fancy geometry way, math way to say that it's not in between these 2 sides right here. Do you see? It's not, this side is not part of this angle at all, is it? So this is the non-included side. So if they give you 2 angles and a non-included side on one triangle, and they give you the same 2 angles in the non-included side on a second triangle, they said they're equal, okay, that L and X are equal, M and Y are equal, then NM is equal to XY. If they give you all that, that's enough to say that these triangles are congruent. So I can now say that triangle, let's call it LMN, is congruent to triangle. Now watch, if I go LMN, I went 1, 2, none. So I got to go 1, 2, none. It seems pretty self-explanatory because the triangles are sitting in the same exact position. But what if this was all twisted around and flipped and that kind of thing? Sometimes it wouldn't be that easy to tell which ones match up. So you go by the angles. This is 1. If I call this LMN, this is 1, 2, nothing. So 1, 2, no arc at all. So we'll call this X, Y, Z. Make sure you do have them in corresponding parts. The L and the X have to match up. The M and the Y have to match up, and the N and the Z have to match up. We talked about that about 2 lessons ago, I believe it was. So what's my reason for this? Why are these congruent to each other? And the beginning of the lesson, we had another reason. It's not angle, side, angle, because the side's not in between. It's angle, angle, side. So this is angle, angle, side. To tell you the truth, watch this. I don't want to mess with your mind too much, but watch. What if, could I say something about N and Z before I even said that the triangles were congruent? Remember we had a theorem that said if we had 2 angles of one triangle equaling 2 angles of another triangle, then the third, remember the third angle theorem? Then the third angle has to be equal to each other. All right, so I could do this. It's just an extra step. Doing angle, angle, side just saves you this one extra step from saying that angle N is equal to angle Z. Because look, if I would have started off saying, all right, 2 angles of one triangle equals 2 angles of another, then the third are equal, then look what I have. I've got an angle, a side, and an angle. So with this information right here, I could use angle, side, angle. But the nice thing about using angle, angle, side is I didn't have to go through that. I didn't have to go through that extra step on my proof. I could have just gone what was given to me right here and just said angle, angle, side. So I hope that makes a little bit of sense on why they even have an angle, angle, side. Notice the angles are next to each other. The side is not included. That side is not in between. So this would be angle, angle, side. I get this question all the time. I'm not going to go through an explanation of it, but you can actually look online. There's several YouTube videos of people that show why this next thing is not true. A lot of people want to write angle, side, side. I'm not even going to write it down. Okay, I'll just put blanks here. Okay, so I'll just put the first letter. There is no angle, side, side. Not because it makes a word that we probably shouldn't say and I don't want to write on here. That's not the reason. Okay, there is no angle, side, side because it doesn't actually work. And that's about all I'm going to say about that. All right, so there is no angle, side, side, or there's no side, side, angle. I'll write it backwards. Okay, so there is no side, side, angle because if you wrote it the other way, it would write a word that you probably shouldn't write. Okay, you get the idea. Without me actually spelling it out for you. I came pretty close, but I didn't. So there is no angle, side, side theorem, but there is angle, angle, side, and there is side, angle, side, and there is angle, side, angle. But there's no angle, side, side. Again, look it up on YouTube if you want to, and there are teachers that give really good explanations of it, and they use real cool programs to show, but I just don't want to take our time with that right now. Let's jump right to some proofs. Now we know, before we do that, now we know 4 different ways. We know 4 ways to prove congruent triangles. All right, and the first way was side, side, side. The second way was side, angle, side. Those were 2 postulates. Then we went into the theorems. The 2 that we did today are theorems, and that was angle, side, angle, and then angle, angle, side. So those are 4 different ways that we have right now in order to prove that 2 triangles are congruent to each other. So that's what we're going to use. We can use any of these, to tell you the truth, to do our next examples. I have a feeling they're going to stick to the ones we're just doing today because that's the lesson that we're on. All right, I've already taken almost 10 minutes just prefacing all of this. Let's do a couple proofs here. Okay, here's our proof. Let's start marking some stuff up. That's the first thing I do, and then we'll look through it. We'll kind of do the proof in our head first, then we'll start writing some stuff down. Don't start writing stuff down right away, okay? Always kind of run through it in your head first, and then we know what where we're gonna go with this. Let's write the stuff down. QS bisects angle PQR. Let's find PQR first. PQR, that's this whole big thing, and it says that QS, this line segment right here, bisects it. Doesn't just intersect it, it bisects it. It splits it into 2 equal angles. So this angle must equal this angle. Why is that true? We got to write down a reason for that. Okay, why is this angle equal to this angle? because this thing bisects it. What tells us if something bisects an angle that the two angles are equal to each other? Well, the definition of an angle bisector does. If you look it up, the definition of an angle bisector says it's a ray or segment or line that divides or splits that angle into two equal angles. So why are these two angles equal? The definition of an angle bisector. But you got to say it bisects first. Okay, we'll write all that stuff down. I'm just kind of talking you through it first. So we know that this angle is equal to this. What else does it say? That angle PSQ, let's find that PSQ. That's this big angle right here. We'll put two arcs on this one. So this angle right here is equal to RSQ, angle RSQ, which is this one right here. Okay, and they told us, okay, we couldn't figure it out on our own. They told us that that was true. So that's nice. So I don't even need a reason why those two are equal. It's just given. They told me, all right? And that's it. That's all they tell me. I'm like, okay, wait a minute. I only have two angles. Everything that I've had so far, all four of those ways to prove triangles congruent, always had at least one side in it. So where in the world is the side? Well, if you take a look at this triangle right here, PQS. That's the one that we're trying to prove is congruent to this one, which is RQS. I've got two angles, and it'd be nice if I had that side that's in between. But if you look at it, look, QS is a line segment that's part of this triangle, and that same exact line segment is part of this triangle. So guess what must be true? Did I change the length of the segment on either one of these? No, I didn't. So we have a thing that says if you have a triangle and it shares that common side right there, I'm just going to put one tick mark, just one tick mark right here. What that means is QS on this triangle is equal to QS on this triangle because it's the same exact segment. So it's not going to change size from one triangle to the other. It stays the same for both triangles. So I can say that QS equals QS, and there's a reason for that. Again, some of this stuff was on chapter 2, so I'm kind of teaching it to you from scratch right now. And we would call that the reflexive property. We're going to write that down here in a second. I'll give you a chance. So we call that the reflexive property. Let's go on. Let's see if we've have enough information to prove the triangles are congruent to each other. Well, look, I've got an angle, I've got a side, and I've got an angle. I've got that same angle, the same side, and the same angle. So guess what I have? I've got angle, side, angle. So now this triangle is congruent to this triangle. I basically just proved it right there. Now we just have to write it down and make it look real pretty. So watch how we do this. The first thing we say, now I'm not always going to jam all the given at the beginning. Most of the time you do put the given at the beginning, but there's a little bit of a twist here. I'll show you what we're going to do in a sec. So first thing I am going to do is, let's start with this angle right here. Why is this angle equal to this angle? Am I just going to say angle PQS is equal to angle RQS? No. You have to say that QS bisects that big angle first. So that's what I'm going to write. I'm going to say that QS bisects that angle, which is angle PQR. And how did I know that it bisects? Well, they told me. That was the only reason. So that's given. Now watch. In the second step, I'm not just going to jam all my given right here. Let's go to the next logical conclusion. If QS bisects that big angle, what does it do to that big angle? It splits that big angle into two equal parts. Let's write those two equal parts down. Even though it's not given, I'm going to say that angle, this angle right here, this top one right here, which is PQS, is congruent to this bottom angle right here, which is, and since we went from this top one to Q to S, let's do the same way here, RQS. Keep everything in order so it matches up. And why is that true? We talked about this a second ago. Remember, this bisected it, didn't it? So it bisected it, which made it two equal angles. What allows you to say that those two angles are equal to each other? Well, the definition of angle bisector allows you to say it. So that's my reason. The definition of angle bisector says that if a line segment bisects an angle, it splits that angle into two equal angles. That's why this is true. And guess what I have right here? I now have an angle. So I'm going to put a little A right here. You don't have to do that. It doesn't do it in the book. I kind of like to do it. I think it looks nice because I've shown one of my angles. Now, that's this angle right here. let's go to the side. Now I know the next given is about an angle, but we're going to go angle, side, angle. So let's go in order and let's do this side right here. So what can I say about that side? Well, watch this. This is nice. This step right here is a really, really easy step that people like, and it should just kind of pop out at you when you do these kind of things. So this shows up a lot. So QS is equal or congruent to QS. So why is QS equal to itself? Remember we gave that a reason? We called that the reflexive. That's how you spell it. Reflexive, and it's a property. So I'll just put a P-R-O-P. Reflexive property. It's like when you look in the mirror, you see the exact same thing. So QS is equal to itself because of the reflexive property. And I'm going to go ahead and put that down. That's one of my sides, isn't it? So let's put side. See how I'm going in order? I knew I was going to go angle, side, and then I'm going to go angle. All right, so I want to see that way in my proof. Hope that makes a little sense. I think it's a good way of doing this. So now, like I said, let's go to this angle. I don't have to really figure out anything. They just tell me that this angle is equal to this angle. So that's my given. I'm going to write that down. So angle PSQ is congruent to, now I want PSQ, so I'm going to go RSQ, and that's exactly what it says up there in the given. And so why are they equal to each other? Because it's given. Notice, I didn't necessarily throw all the given at the beginning. I wanted to go in a nice logical order. So what did I just show right there? I just showed my third angle. See, there's one angle, there's the side, there's the other angle, so I'm going to write that right there. And now it's nice and pretty. Watch, ASA, angle, side, angle. So that allows me to say that those triangles are congruent to each other. Okay, that's kind of cool. So, and that's what we wanted to prove, isn't it? And we're basically done after we give the reason for this. So triangle PQS is congruent right up here to triangle RQS. RQS. And what's my reason? Look, my reason is right in green in the parentheses right here. Angle, side, angle. That's why I like to put it there, because it just kind of stands out a little bit. And that's it. That's my proof. I just proved that this triangle was congruent to this triangle. All right, let's take a look at this thing right here. That's pretty crazy. All these angles that or sides that intersect each other and all that kind of stuff. But let's mark the thing up and let's see what we're trying to prove, and then we'll go from there. All right, let's take a look. Angle DAC. Let's find DAC. There's D, there's A, there's C, so it's this angle right there. That angle is equal to angle BEC. There's BEC, so that would be this angle right here. Sometimes they get a little tricky, especially when they overlap like they're doing right here, because you do have a couple triangles that are overlapping. It gets a little bit tricky, but that's where you really got to go with the letters and you know what matches up with what. Sometimes you can't just always look at it and see what you think might be equal to each other. What else do they tell you? That DC and BC are equal to each other. DC is this segment right there, and it's equal to BC, which is this segment right there. That's just one. Let's get rid of that. I was trying to make it a little thicker and then I messed it all up. Okay, right there and right there. Okay, so that's what we have. And what are we trying to prove? We're trying to prove that triangle ACD, let's find ACD. ACD is this one right here. Now, I thought about like filling it in, but then you got to fill in another one and they're going to overlap and it gets a little ugly. But I'll show you something that you might be able to do. Let's just look at the other triangle though. Okay, so the first triangle is ACD, which is this one right here, and then ECB. ECB. This one right here. So you see that they do overlap. You kind of have to mentally separate them, or you could separate them yourself. You could take ACD, redraw it down here, and then take ECB right here, redraw it here, mark the stuff that's equal, and then you might be able to go from there. Sometimes that's helpful. In fact, let me do that. I won't make you watch me do it, but I'll just separate them, and then we'll take a look at it. Okay, there they are separated. Now you don't necessarily have to do this. If you could keep those straight in your mind, then that's perfectly fine if you want to do that, okay? But I just thought I'd separate them. For some people, it could be pretty helpful. I think some of that might be off screen a little bit. Let's move this, scooch this over just a little bit. Okay, it's still it's not quite there. Let's go a little bit more. All right, that's pretty close. All right, so let's see what we have here. I've got an angle and I've got a side equal to an angle and a side over here, but I don't have anything else, okay? I don't have something with just two things, just an angle and a side. I need something else, okay? And what do I need? Well, I could use another angle, right? I could go angle, angle, side, or I don't know. Do I know two other sides? I don't know any other sides, to tell you the truth. So what in the world else do I know? Well, if you take a look at it, remember they overlap each other. They share something. Look at this triangle right here, and look at this triangle right here. These are the two triangles I've separated. What do they share? And if you look down here where they're separated, it's actually the same letter. Do these two triangles have the same letter? Yep, they have angle C and angle C. Because look, they overlap and they both share this angle C right here. This C in one triangle is the same C in the other triangle. Remember what we did on the last problem? We said reflexive property. And that reflexive property, we dealt with a side, a line segment, but you can also deal with angles and reflexive property. And so that's exactly why angle C is equal to angle C, because of the reflexive property. Now, let's take a look. Are these triangles congruent to each other now with this information? Well, I've got an angle, and a non-included side. This side is not in between those two angles. I should put two arcs here. So I've got two angles and a non-included side. I've got the same two equal angles as these and the equal non-included side. So guess what's true about these two triangles? These two triangles are congruent. So I would say that triangle ACD is congruent to triangle that's an ugly triangle, ECB. And what's my reason? It's angle, angle, side. Let's make sure they match up. The A and the E. Did the A and the E match up? Yep, because they're two equal angles to each other. The C and the C, of course, because they're the same exact angle. And then the D and the B, they don't have any arc and they match up. So if you look at it, you'd actually have to take this and you have to twist it around, okay? You have to take this and just kind of turn a little bit so this matches up with this one, this matches up with this, and you'll have to flip it so this matches up with this. So you have to flip it and twist it. Sometimes it's hard to see that, but you can always just go by what's given. So these two triangles are congruent because of angle, angle, side. Okay, on the last one, I didn't write down all the reasons, and I probably won't here just for the sake of time. But I did explain, all the steps. So you could probably put all the steps in. So we'll do the same thing here. Let's put the given in. Line segment RQ is equal to or congruent to line segment ST. So RQ and ST, they're equal to each other. So I'll put a tick mark here, tick mark here. It means the length of them is the same. Okay, RQ is the same length as ST. Now look, they tell you something else about RQ and ST. We haven't done this yet in a proof. But we have seen this in another chapter, that RQ is parallel to ST. RQ is parallel. And you're like, what in the world? I thought we were done with that parallel stuff. Nope. We're going to be using that quite a bit all year, about the parallel lines and transversals and all that kind of stuff. That's all they tell you. They just say they don't tell you any angles are equal. They just tell you this one side is equal to this one side and this side is parallel to this side. They want you to prove that RUQ, this triangle over here on the left, is congruent to TUS, which is this triangle over here on the right. Well, if we think about it, let's see. What do we know about parallel lines? You remember that? Parallel lines cut by transversal and all that kind of stuff. Here are my two parallel lines. I could look at ST as being a transversal. You see that? Here's my parallel lines. Here's a transversal. What do I know about two lines cut by transversal? I know that I've got some angles that are equal to each other. And here's what I'm going to look at. I'm going to take a look at angle R. And here's my transversal. So what could I say then? If these two lines are parallel to each other, angle R equals angle T. For what reason? Because they're alternate interior angles. That's why I wanted you to learn those words, because we're going to use them in these proofs as a reason. That would be my reason. So I've got a side, and now I have an angle. All right. If you wanted to do that, you could say there's my side, there's my angle, right? And what else? I'll just do it for one of those. And what else? You got a couple other things that you could do this two ways, okay? There's not always just one way to do a proof. You could say that this angle is equal to this angle, all right? That would be a pretty good way. What's the reason for that? Okay, well, they're vertical angles. Remember that. We've talked about that, and vertical angles are equal. That would be a reason in your proof that you would say angle RUQ and SUT are equal to each other because vertical angles are equal. And now look, I've got two angles and a non-included side. So the reason that these triangles would be congruent to each other is because of angle, angle, side. Let's say you didn't see the vertical angles. Hopefully you did, because they really stand out, the vertical angles. But let's say you said that, okay, these two right here alternate interior angles, so they're equal to each other. Well, I've got another transversal here, don't I? This one right here is also a transversal. And let's make this one back to white, okay? This one right here is also a transversal. So what must be true about, let's change this to red. What must be true about some other angles? Look at this. I could have said that this angle is equal to this angle. And what would be my reason for my triangles being congruent? This time it's not angle, angle, side, because look where the side is. The side is the included side. So you could actually do this two different ways. You could have used the vertical angles and said angle, angle, side, or you could have used both pairs of alternate interior angles and said angle, side, angle. So you can see that there's several different ways that you can do these proofs. And it's kind of cool to see where that parallel line stuff and alternate interior angles came in. You're going to see that quite a bit also. So look for that. Whenever you see parallel lines, the first thing you need to think of is alternate interior angles. Again, we're going to do more of this in class, okay? We're going to do a lot of this together. I'll let you work on some things. I'll walk around and help you out and that kind of thing. So don't freak out too much on this stuff. I know it's brand new to you. I know it's a little weird, and traditionally students struggle with this a little bit, but you be different and keep an open mind to it, because it can be pretty cool. It's kind of like a little puzzle trying to figure out, unlock the key on why these things are congruent and that kind of stuff. All right, so we'll see you in class, and we'll give you some extra help in class if you need it.